Hey there, welcome back. This is Professor Hank, and in this video, we are going to talk about class constructors in the C++ programming language. Okay, so let's go ahead and get started. The items we're going to discuss related to constructors are going to be the constructors themselves. And basically what a constructor is a special method for a class that is automatically executed whenever a class is instantiated. So when you create an object, this method is going to automatically execute, right? It's not going to require any extra method calls on behalf of the programmer. This method is just going to automatically execute, okay? We're going to talk about what a default constructor is. Basically, that's a constructor that requires no arguments. We'll talk about passing arguments to constructors. Going to need a slightly different syntax for doing this than you would with regular methods. Going to talk about what happens with a class that has no default constructors, right? It's possible to write classes without constructors, so what happens in that situation. Then we want to talk about the option of overloading constructors. Remember what overloading means is that you can have methods that have the same name, just different parameter lists. And then we'll finish off by talking about the fact that you can only have one default constructor. Okay? All right, so let's get started here. Okay, so a constructor is a member method that is automatically called when an object is created. Right, so you've got some class you wrote, class foo, and you want to create an object based off of that class. So you have a statement that looks something like foo f semicolon. Okay, so when you do that, then the constructor method is automatically invoked, and any code that's inside of that method is going to execute automatically. Right, and so the purpose of this thing is to construct the object, to set it up in memory, to initialize variables, that sort of thing. Okay, the constructor function is going to require that you name it the same as the class name, right? And that's how you specify that this is the constructor method. This is the method that is going to automatically be executed. Okay. In addition to this requirement that the name of the function matches your class name, the constructor has no return type. Okay, so let's look at an example program showing you how to create a constructor, right? So I'm going to go ahead and write a class, which I'll call foo. And class foo is just going to be a stupid class. All it's going to do is store an integer, right? Foo will just store an integer, and that's going to be it, right? So we'll have a private data attribute, which I'll call x, right? And then I'll have my public interface, which is going to include an accessor and a mutator. So we'll have a method called setX, right? And then we'll have a method called getX. And then we'll add a method that is going to be our constructor, right? So setX is going to be our mutator, and getX is going to be our accessor. And as part of our public interface, we're going to have our constructor. And the constructor is going to have the same name as the class and no return type, right? So this is our constructor. Okay, so let's define these methods, right? And so the first method I'll define is the constructor itself. So this constructor belongs to class foo. Again, no return type. Name of the constructor, same as the class. Okay, and all our constructor is going to do here is just initialize the class, right? So what I want to do is I want to make that x variable initialize to 0, just so there's no garbage in it. Okay, so I'll go ahead and define the mutator and the accessor here just to finish the class off. So set x, right? And set x is just gonna set x, right, to its argument, and then get x, right? So void foo, oops, returning an accessor. So foo get x, okay, and we're gonna return x, okay? So let's go ahead and create an object of type foo. Right, this is going to instantiate our foo object, and when we do this, this causes the constructor to automatically execute, right? And when we do that, what's going to happen is when this object gets created, this method right here automatically going to execute. And so that's going to cause x to get initialized to 0. So rather than having a garbage value inside there, x is going to have 0 in it, right? So then I can show you what's inside of x. Right? It's going to be just plain old 0, right? So here's the code for the class, so you can see that all on one screen. And then I'll go ahead and compile this thing and run it. Let's see here. Oops, let me go to my desktop. C++.cpp. There we go. And I'll go ahead and run it. Right, so you can see the 0 because I initialized the constructor. Okay, so let's talk about default constructors. A default constructor, when we use that term, we're referring to a constructor that requires no arguments. So in my previous example for class foo, that constructor was a default constructor, didn't require arguments. More on this in just a few minutes. Now, if you don't write a constructor, like I did for class foo, I did include a constructor, I did write a constructor for that. If I hadn't, then the compiler is going to include one for you, right? Your original source code isn't going to change any. It's just that when your source code gets translated into machine code, a constructor will be implicitly included, right? It'll be done for you. Now that constructor doesn't do anything, but behind the scenes, under the hood, that's what's going on. A constructor is going to get provided, is going to be created when the translation happens, whether you explicitly write one or not. Okay, now a default constructor is called as a result of a simple class instantiation. So as I was saying, create a variable of type foo, right? That's going to create a foo object, and so that's going to cause the default constructor to execute. Okay, so now let's talk about passing arguments to constructors, right? A constructor is a method, and methods can accept arguments, therefore constructors can accept arguments. So if we're going to create a constructor that's going to take arguments, then we're going to include some parameters in the parameter list, right? So for the prototype, make sure that you specify the type and number of parameters that you're going to have. For our example for class foo, we'll just have one parameter that we will use to allow us to initialize the X data attribute to whatever we want, right? So once we've included that in the prototype, then we also want to make sure that in the method definition, we include that parameter as well. Okay, so how do we pass arguments to constructors? Well, the arguments are going to be passed to constructor whenever you create the object, right? So before, when we instantiate a class to create the object without a constructor that accepts arguments, we just said foo f and then semicolon, right? Well, now we want to pass an argument to one of the parameters, and so we're going to include in parentheses our argument list, right? Just like we were calling a standalone function, right? If this was a standalone function, we wanted to call f and pass it 99, we would just write that, right? Well, since this is a constructor, we have to call it at the same time that we're instantiating the object, so it's going to be part of the entire definition for that object. Okay. All right, so let's go back to our foo example, and we will add to it a constructor that accepts arguments, right? So let's rewrite our default constructor to accept arguments, right? So we'll modify the prototype to have a parameter, and then we will name that parameter in the method definition, okay? And now we'll take that parameter and we'll assign it to our data attribute. And so when we do this, whatever value that we pass to the constructor is going to end up initializing our data attribute, okay? So if we go back to main now, we're going to have to add an argument list, right? That matches our parameter list. So let's say 99, okay? So now when I run this, I'm going to see 99. Why? Because the 99 argument was copied into the constructor's parameter, which was then assigned to our data attribute x, which I then retrieved by using accessor getX, right? And we see 99 on the screen. Now, it is possible to write classes that do not have a default constructor. That is to say that when all class constructors require arguments, there is no default constructor. If that's the case, you have to pass the required number of arguments to a constructor when you create the object. So for example, in our updated foo class, there is no default constructor. Why not? Because the only constructor that exists is a constructor that requires us to pass an argument to it. So what this means is that if we're going to create a object of type foo, we have to have a statement where we're passing the correct number of arguments. In other words, I can't do this, right? I can't just create or try to create a foo object without passing arguments. If I try to do that, I'm not going to compile, right? Because there is no default constructor, which is to say that there is no constructor that requires no arguments, right? So the only way this is going to work is if I actually pass an argument to the constructor and the required number of arguments here, right? So now it's going to work just fine. Now, constructors are functions, and as you may recall, functions can be overloaded. Overloading just means that you have multiple functions, multiple function definitions. They've got the same name, but they have different parameter lists, right? So classes can have more than one constructor, and it just requires different parameter lists. So for example, I could have 3 different versions of my foo constructor. One that requires no arguments, that would be my default constructor. One that requires 1 argument, and then maybe another that requires 2 arguments. Okay, so let's add some overloaded constructors to our foo class, right? So right now I don't have a default constructor. I just have a constructor that's going to accept 1 argument. So let's add a default constructor, okay? This is going to be my default constructor. Why? Because it accepts no arguments, right? So in addition, let's add another constructor that accepts 2 arguments, right? So this is a constructor also. Okay, so let me define the default constructor. And the default constructor, we'll just have it initialize x to 0. Okay, we'll leave the 1 parameter constructor alone, and then I'll add a definition for a constructor that is going to accept 2 arguments, right? And so what this constructor will do, it's a silly example, we'll just initialize x to the sum of the 2 arguments, right? Just so I can show you how this works. Okay, now once I have these three constructors, right, I can now choose how I want to instantiate the foo class, right? So I'm going to create a foo object, but only one constructor ever gets executed. Only one, right? Only one of these constructors will get executed. Okay, so which one is going to be determined by the argument list that is provided. Okay, so let me go down and give you examples, okay, in main here. So this right here is going to cause this is going to cause the one parameter constructor to execute, okay? And we'll call this guy right here E, right? So this causes the zero parameter constructor to execute, and this is going to cause the two parameter constructor to execute, right? So what I've done is I've created three different foo objects, right? And the foo objects have been initialized in different ways. E is going to call its default constructor, which is going to cause its x to store 0. F is going to call its one parameter constructor, which is going to cause its x to be initialized to 88. And then G is going to call its two parameter constructor, which is going to cause, in this case, its x to be initialized to 15, because its two parameters are going to contain 5 in A, 10 in B, and so 5 plus 10 is 15, and then we're assigning 15 to x. Again, it was kind of a stupid example, but I just wanted to show you how the overloading of the constructors works, right? So now, if I show you the contents of E, that's going to show you 0. Then we're going to see f dot get x. That's going to show you 18, or excuse me, 88. And then if I show you G's x by calling its get x accessor method, that's going to show you the 15. Okay, so there you go, 0, 88, and 15. So there's the definitions of the overloaded constructors, right? And there is their different parameter lists and their different prototypes. Okay, so next thing I want to point out to you is that a class can only have one default constructor, right? So you can only have one method in your class. That's a constructor that requires 0 arguments, right? So take a look at both of these method prototypes for constructors, right? We've got the first guy, right? The top one here that has no parameters at all, right? So looking at that, it's going to obviously not accept any arguments, therefore it would be a default constructor. But if you look at the second version of that constructor prototype, you'll see that there is a non-empty parameter list there, right? And we've got inside of there int equals 0. Well, what is that? Well, that's a default argument, right? So you may recall from your earlier studies on functions, default arguments, what are those? Well, default argument allows you the option of assigning an argument to a function call or not, right? So in this case, with this second version of a constructor, I can either pass an argument to that constructor or not. If I don't, then 0 is automatically assigned to its parameter, right? So I could not have both of these constructor definitions in the same class. Won't compile, because compiler won't be able to tell which one should be default, because neither one of these requires you to pass any arguments. Okay, so let me quickly tell you about destructors. Okay, a destructor is kind of the opposite of a constructor. A destructor is a member function of a class that is going to automatically execute when the object is destroyed. Object can be destroyed when it goes out of scope, or when you delete a dynamically allocated object, right? Either of these actions is going to cause the destructor for a class to execute. Okay, so they're kind of like the opposite of constructors. Now, typically a destructor is used to free memory. Your class may have dynamically allocated some memory in its constructor, and so before the object goes out of scope, before it dies, last thing it wants to do is say, okay, let's free up that memory so that way we don't have any memory leaks, right? Classes should be these self-contained things. The objects that are instantiated from the class, they should take care of themselves. They should set up any memory that they need. They should initialize any data attributes they have, and then before they die, before they leave memory, they should clean up any memory that they created, right? They should clean up after themselves. So a destructor, the syntax for this is a destructor is going to have the same name as the class, just like a constructor does, with the exception that it's going to be prepended with a tilde, right? That's the little squiggly character that's just above your tab on the keyboard. Okay, and destructors will never accept arguments, which makes sense because what would the object do with the arguments, right? The destructor is the method that executes right before it dies, so the object isn't going to be around anymore to use those arguments, right? But an implication of this is that since a destructor can never accept arguments, it can't be overloaded. Okay, so let me show you an example of destructors in a class that uses dynamic memory allocation, right? So class foo still going to store an integer, but we're going to dynamically allocate the integer variable that's going to store the integer. So as such, we're going to need to have an integer pointer to store the memory address of our dynamically allocated integer variable. Okay, and our default constructor is going to be responsible for dynamically allocating that integer, assigning its memory address to our data attribute, which is our integer pointer called x, and then it's going to be responsible for initializing that dynamically allocated integer to 0. Okay, so to avoid memory leaks, we have to make sure that that dynamically allocated memory gets deleted, and so we want our class to clean up after itself, so we're going to include a destructor. And destructors have the same name as the class, but prepended with this tilde character, tilde, don't know how to pronounce it, but that's what it is. Okay, and they never take arguments, therefore no parameter lists. This is our destructor. Okay, so let's define the methods for this thing, this class or this version of foo that's going to use dynamically allocated memory. So we'll have our default constructor, and that constructor is going to dynamically allocate an integer variable, and we're going to assign its memory address, which is returned by new, to our integer pointer x, and then we're going to assign to that dynamically allocated integer variable some value. We're going to initialize it to 0 just like before, and so to do that we have to dereference the x pointer by using that indirection operator, and then we can assign 0 to it. Okay, so right now we've got ourselves our variable set up. So our destructor is going to be responsible for freeing that dynamically allocated memory, right? So basically all that means is that this method is just going to delete the integer variable whose memory address is in the x pointer. Okay, and then just to finish out the class, I'll go ahead and define set x and all that does is go to the memory location whose address is in X by dereferencing X using the indirection operator and putting the parameter or assigning the parameter to it, and then the accessor just retrieves the value that's in that memory location whose address is in X. Okay, and that's that. So let's then go ahead and create a foo object. Okay, and that's going to execute the default constructor. Okay, and what's the default constructor do? Creates a new integer variable, takes the memory address of that new integer variable, puts it inside of X, dereferences that memory address inside of X to gain access to our dynamically allocated integer variable, and puts 0 inside of it. So basically what that means is that this class creates two variables, right? A pointer that's statically allocated, and then an integer variable that's dynamically allocated. Okay, so anyway, so it's going to create that, and 0 is going to be inside that dynamically allocated integer variable, right? And so then I'll go ahead and invoke getX, the accessor. That's going to show us 0 because right here we're going to access that dynamically allocated integer variable by dereferencing the pointer that stores the memory address of that variable, and then getting that 0 out of it and then returning it. Okay, so let us compile this and execute it, and you see that it's 0, right? And so no memory leak, right? So constructor sets up the object, Destructor tears it down, and there you go. Okay, so let's go ahead and summarize what we talked about in this video. In this video, I introduced you to constructors. Constructor is a special method that is automatically executed when you instantiate the object. We talked about what a default constructor was. Default constructor is a constructor that requires no arguments. We talked about passing arguments to constructors, and that's done when you instantiate the object. We talked about the implications of classes with no default constructors. What happens with that? Basically, compiler is going to write one for you that does nothing. Talked about overloading constructors. Constructors are methods. Methods are functions. Functions can be overloaded as long as the parameter list is different. And I showed you that you can only have one default constructor. Gave you an example of a problem with that, where I wrote two default constructors, one that had no parameter list at all, and one that had a parameter list that included a default argument. Right? Can't have both of those in the same class definition. And then at the end, I squeezed in destructors. Right? And a destructor is the opposite of a constructor, typically used for cleaning up after the object, for tearing it down, for freeing up dynamically allocated memory. But remember, inside of a constructor or destructor, they're both functions, right? They're methods of the class. You can put inside of those things whatever code that you want. Okay, so I gave you simple examples. So the code that I needed inside of those methods was simple, but they're functions. You can make them as simple or as complex as you need to, based off of the requirements. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.